back everyone to part 3 of the Unreal Engine 5 tutorial series on Smart Enemy AI. In this part we're going to be covering perception. So here I have an enemy that's patrolling along a route, and if I make a noise, the enemy perceives the noise and goes to investigate. So we're also going to be creating an investigation state. And if the enemy then sees me, I'm going to make a noise, the enemy sees me, they're going to switch to attacking automatically. Now I'm also going to show you how to debug the AI perception system using the AI Debugger so that you can see the sight radius, the hearing radius, and so on. And we're also going to be adding the investigation state to our behavior tree. So let's get started. So last time, this is where we left off. We have an enemy patrolling along a route, and if I press 1, I interrupt the enemy and get him to attack me. And if I press 1 again, he stops attacking me and goes back to patrolling. Now we want to set up perception system so that the enemy doesn't, I don't have to press 1 for the enemy to attack. The enemy just sees me and starts attacking automatically. So first thing we're going to do is we're going to open up our AI controller inside our enemies AI folder. And we're going to add a perception component to our enemy. So over here in the components, look for AI perception. And if you click on it, here is where you can configure all your different senses. So first thing we need to do is pick a dominant sense, and I'm going to choose AI sense sight. And dominant sense is just that if there are two conflicting senses that tell the enemy where something is, it will use the location of the dominant sense. And then click on the plus icon here, and let's add our first sense config. So let's start with sight. So choose AI sight config. And if you open this and open sense as well, here is where you configure the sight. So the sight radius is the radius in which the enemy can see something. So for testing purposes, let's put this to say 1,000, or let's say 800, so it's a bit smaller. Lose sight radius, this is the radius which the enemy will lose sight of something. So how far does it have to be for the enemy to not see it anymore? So here, let's say something like 1,200. And the peripheral vision half angle is the the half angle at which the enemy sees from each eye. So 90 degrees on this side, 90 degrees on the left side. That means that the enemy can see 180 degrees perfectly on both sides. Humans can't see 90 degrees perfectly, so let's drop it down to say 60, so that it's a cone in front of the enemy. This can be left as is, this as well. The one thing I do want to talk about though is max age. So after the enemy sees something, and that something goes out of sight, how long should they remember it for? So how long should it stay in the array of things that the enemy knows something about? So for this one, let's do like 5 seconds. That means if I exit outside the sight, the lose sight radius of an enemy, after 5 seconds, the enemy forgets about me. And then you can do something on the event that the enemy forgets about you. And that's our first sight, that's our sense, our sight sense. Let's see how we can actually debug senses in our editor. So back here in our editor, I'm going to press play. Oh, actually, I want the enemy to be standing still, so I'm going to go over here, search for patrol. Now I've clicked on the cube, search for patrol, and I'm going to remove the patrol route from the enemy so that they default to their idle state. Now the enemy is in idle state. If I press the apostrophe key on the keyboard, and this should be also the same for everyone, the apostrophe key will open up our AI Debugger. And on top here, you see a lot of useful information. And this is how you can switch between debugging different things. Now, if I press 0 on the numpad, I debug navmesh. If I press 1, I debug AI, behavior tree, so far. Now, I don't have a numpad, so I've reconfigured these to be just regular numbers. And you can edit these in your editor preferences and your project preferences anytime you want. So if I press 4 now on the keyboard, this is the debugger for the enemy. So you see here, this is the 60-degree half angle that we set. The green one is the sight radius, and the pink purple one, that's the lose sight radius. One important thing I forgot to mention is if we go back here to our AI perception, is this detection by affiliation. And you'll see here, this is the types of enemies or types of actors that an enemy can detect, whether they can detect enemies, neutrals, or friendlies. Now, this is built for the team agent interface that's only available in C++, so we can't use that here in Blueprints. So I'm just going to select all of them, meaning that the enemy detects everything, they see everything, and then once we get the actor that they see, then we can check, is this actor a player, another enemy, or whatever. But we're not assigning teams to them, like enemy team or neutral team or friendly team, through the team agent interface. Now, you can do that if you want to dive into C++ and just assign different teams to different actors. It's quite simple. It's not very complex, but for our use cases, we don't really need it. So now that the enemy is detecting everything, if I go back here, press the apostrophe key again, and 4 for perception, now you can see that there's a green circle or a green sphere around me. That means the enemy is detecting me. And if I go outside this pink area, now the enemy has lost sight of me and the age is starting to count down. As soon as it reaches 5, which is the max age we set, the enemy loses sight of me and forgets me. Now in here, the enemy can't see me because I'm not in the green radius, sees me again. If I go outside of the site, again, starts to count down, 2, 3, 4, 5, and the enemy forgets about me. So this is how you can debug your senses. Now, let's add another sense. So if I go back here again to my AI controller, let me close this site down, and I'm going to click the plus again, and I'm going to add a hearing config this time. So open this up again. And this is the hearing range. For debugging purposes, I'm going to make it a bit smaller than the lose sight radius. So about, let's say, 1,100. Actually, no, let's just make it very small so you can see where it is. So 500. And the max age, let's set it to like 3 seconds or something. And again, for your game, play around with these numbers depending on how big or small your levels are, if it's a range or a melee game, these numbers will vary a lot. So make sure to play around with them. And detection by affiliation, again, select all of them. If I go back here, press play, apostrophe key, and 4 for perception. Now I see that there is a new circle drawn around the enemy. So if I go here behind the enemy where he can't see me, he can hear me though, but I need to actually make a noise. And noise has nothing to do with the audio system in the game, so playing sounds isn't making noise. Making noise is its own system, and let me show you how we can use that. So if I open up my player blueprint here, I'm just gonna create a new custom event somewhere. Actually, no, I'm going to create a new keyboard event. So keyboard, when I press, I don't know, F. Yeah, when I press F, let's make some noise. And out of this, search for make noise. There's make noise and pawn make noise. We want just make noise. And this is the event that actually makes a noise that an AI can detect. And it takes a few things. The noise location, where is the noise coming from? So I'm just going to get my actor location of the player. So the noise is where I'm currently standing. And a loudness. So this is the relative loudness to the range. So 0 means no noise and 1 means full noise. And if you're using max range, then the loudness is affected. If you're not, loudness doesn't do anything. And max range is sort of a sphere around the noise where it can extend. And if the sphere that the actor making noise overlaps with the sphere of the actor's hearing radius, then they hear something. Now, I don't recommend playing around with this right now because it's a bit finicky and you have to play around with the numbers. So I'm just going to leave it as is. And the noise instigator is just a reference to self. Now for our purposes, let's just spawn an emitter so that we see something as well. And let's do an explosion at the actor's location. And also let's play a sound. Again, this has nothing to do, just this node is enough to make noise. But let's also play a sound so that we hear something. I'm going to choose the explosion cue. Both the explosion effect and explosion cue come with the starter pack, by the way. All right, so now if I go back here, apostrophe key, press 4. Now the enemy sees me. Now if I press F, let me do it behind him. So the enemy can hear behind him, but he can't see behind him. Now if I press F, now you can see he heard something here and the countdown is starting. And after 3 seconds, he forgets the noise. F, here's the hearing, 3 seconds, gone. So you can see that the enemy can, of course, hear inside this circle, and outside, enemy can't hear anything. And he can, of course, see me and hear me at the same time. But hearing is, of course, coming from a location, so he hears something at a specific location. All right, so next up, let's set up a third sense, which is the damage sense. So over here again, click a plus icon and choose, where is damage? Yeah, damage sense config. Now damage sense is, of course, when an enemy gets damaged, they notice something, of course. And this is very simple. It only has a max age. There is no team agent interface or radius because, yeah, if someone damages them, then they damage them. It doesn't matter who they are. So let's also add like a 5 second here. And we need also an event that applies damage to the enemy. So if I go back here to my player, do keyboard event on pressing X. Now search for damage event, report damage event. Now again, getting damaged through apply damage to actor, for example, doesn't trigger the AI damage event. This is what triggers the AI damage event. And the damaged actor, let's get, this is just for debugging purposes, so I'm just gonna get the only enemy actor in my scene. And the instigator who instigated this damage is myself. Damage amount, let's just put a random number here. And the event location is the get actor location. So where is the actor that damaged this enemy? All right, now if I go here, apostrophe key, press 4. Regardless of where I am, if I press F, oh, sorry, not F, we said X. If I press X, I damage the enemy, and then the enemy realizes that a damage event came from somewhere. So I can be way over here, press X, and still the damage event will be registered. Because wherever you are in the world, if you damage the enemy will notice damage. It doesn't have to be in a specific radius. All right, so now we have our perception system set up to sense 3 different senses: sight, hearing, and damage. Now we want the enemy to do something with this information. So how do we get the enemy to listen to these events and do something when they hear a noise or see someone? Let's see how we can do that. All right, so back here in our AI controller, let me close this. And in our event graph, there is a event on AI perception. So if you click on AI perception here, and on the right, you see an event called on perception updated. Now, this event is called when an enemy perceives anything out of all of their senses on any actor. And it gives you a list of actors that it perceives something about. But what we want to check is, does the enemy see the player or hear a sound, or was the enemy damaged by something? So first, we're going to create a handy function here. Let's call it can_sense_actor. And this function will take 2 things. It will take the actor that we're asking if we can sense something about. And this is going to be of type actor, object interface. And we want to take another parameter called sense, which is which sense are we currently asking about. So can the enemy hear this actor? Can the enemy see this actor? For this, I'm going to actually go over here in our enums folder and create a new enumeration. Search for enum. And we're going to call this e_AI sense. And let's open this up. And we're going to have 3 senses, 4 if you count none. So none just means that's not sensing anything. It's always good for enums to have a default value in case you want to sort of disable it. Then we're going to have sight. Then we're going to have hearing. And we're going to have damage. These are the 3 senses we set up. And back here in our canSenseActor function, we want to return... Oh, I put these on the output node. Sorry, these should be on the input node. Actor. And the other one is sense. And we're going to use our enum that we just created. AI sense. And for the return node, we want to return a Boolean whether we sensed the enemy or not, or the player. How we're going to use this is that for each actor, we're going to loop over them and check, can I sense something about this actor? So can I sense sight? Do I see this actor? I'll plug in the array element because we're looping over actors. So the array element is an actor, so plug it in here. So can I see this actor? Can I hear this actor? And was I damaged by this actor? And then if this is true, I'm going to go down here and branch. This is true, then yeah, I'll do something. But let's first implement this function. So there's a very handy function in the AI perception. So pull off of your AI perception component here and search for get perceived, what was it called? Get actor perception. Get actor perception. This takes in an actor, which is the actor we're currently asking something about. And it returns this info. Now, if I pull off of this infrastructure and break it, you'll see that it has something called last sensed stimuli. So for this specific actor, give me all of the senses that you have about it. So can you see this actor, can you hear this actor, and can you be damaged by this actor? So this array contains all of the 3 senses that we set up in the perception system. Now I can loop over them again. So that means for each actor, I'm looping over all of my senses. And this gives me an AI stimulus structure. Let me also break this. And this is information about this specific sense. Its age, its strength, was it successfully sensed or not? Now, this is slightly complicated, I know, but let me recap really quick so you're on the same page. We get an actor. We get everything that we perceive about this actor, and we check all of our senses. And we want to check now this sense enum and the sense stimuli. If they're the same and it's successfully sensed, that means the enemy can see me or hear me or so on. So there's also a nice function off of the AI stimulus here that's called getSenseClass for stimulus. And what this does is that returns a class for the AI sense. And the classes you have are AI sense sight, AI sense hearing, and AI sense damage. Or at least these are the ones that we set up over here. So I'm going to check if this class is equal to something. So I can, of course, write here if it's equal to AI sense, then and successfully sensed is true, then the enemy sees me. But we want to check first our enum here that we're checking against. So I'm going to pull off of this node and choose a select node. Now in the select node, let me remove this for now. In the select node, if I plug in our enum as the wildcard, Then for every sense, it asks me to select the class that belongs to it. So for sight, I'm going to select AI sense sight. For hearing, I'm going to select AI sense hearing. And for damage, AI sense damage. Again, what this means is that for each actor that you perceive something about, and for each stimulus, for each sense you have on this actor, get the class of that sense and check if it's equal to the sense I'm currently asking you about. If it is equal, so do a branch here. If this is equal, then we want to know, is it true or not? Do you hear this enemy? Do you see this enemy or this player? So for this, we're going to break our stimuli here, and we're going to return whether successfully sensed is true or not. And you can actually return the entire stimulus object because we might need this later on. And let's call this stimulus, which is all of things here. All right, let me just tidy this up. So how do we use this function now? Now back here in our event graph, like I showed you, now I can say for this actor, do you sense sight? Do you see this actor? And if true, let's just print sensed sight. Now we also want to check the 3 other senses. So let's move this here and create a sequence node. Sequence allows me to do multiple things in sequence. So the first thing is, can you sense this? Can you see this actor? I'm going to copy all of this. The second one is, can you hear something coming from this actor? And don't forget to plug in the actor. And the third one is, are you damaged by this actor? So here I'm going to say sensed sound, and here I'm going to say sensed damage. And remember, this is called on perception update. So whenever the enemy perceives anything new from any of their 3 senses, this is called. So it's called fairly regularly. So let's go back here and press play. Now, one thing to note, you see here nothing is being printed. This is a bug that happens, I think, in versions, not really sure which versions of the engine, but if you open the AI debugger and then close it again, sometimes printing stops working. So I'm just going to restart the engine, and that fixes the issue usually. All right, so I restarted the engine. Let me open back up the assets I had open, and let's see now. Okay, so now printing is working. So you see I'm behind him, he doesn't sense anything. I go in front of him, sensed sight is printed. Now if I press X and damage him, sensed sight and damage because he sees me and I'm damaging him. Now if I'm behind him and I press F to make a noise, then sensed sound. And if I go in front of him, sensed sound is still being printed. And the reason is he hasn't forgotten that sense yet because we set the max age to 3 seconds. So if I keep doing this, sense sight and sound, here just sound, and so on. So this is working correctly. Now on every time the enemy senses something new, we can understand what is being sensed. Now let's do something with this information. So on sense sight, instead of printing, let's actually do something useful. Let's delete that. So I'm going to create a new function here and call it handle sensed sight. What do we do when the enemy sees something? What we want to know here is what is that something we're seeing. So let's pass in an actor. Search for actor object reference. And what we're going to do is change the state. So we have this set state as attacking function, if you remember, that takes in an actor. And back here in my event graph, I'm just going to call handle sensed sight. And the actor is this array element that I'm currently looping over. So now let me actually start here behind the enemy. Now the enemy is passive. When I go in front of him, he should see me and start attacking. Yep, enemy sees me and starts attacking. Nice. Here is the first smart behavior that we've implemented so far. And remember, this is going to be called every time the enemy senses anything new. So there's a few things we still have to do here. If the enemy is dead, for example, they shouldn't attack me, even if this function is called. So we want to first check what state the enemy is currently in. So I'm going to create a new function here called getCurrentState. And remember, we have a state stored in our Blackboard. So I'm going to get Blackboard the variable, not the function. And I'm going to say get value as enum, because we know the state is an enum. And the key name is going to be our state key name here from our variables. And we want to return this value. So I'm going to go here and in the output add a state, and it's going to be type E_AI state. This is the enum we created last time, if you recall. So I'm just going to plug this in here. And this converts it from a regular enum to this specific enum. All right, and back here in our handle sense site, I'm going to first call getCurrentState. And I'm going to do a switch statement. So here, all these pins, how I'm going to handle that specific state. So if I'm passive, I'm going to switch to attacking. If I'm attacking, I won't do anything. If I'm frozen, I also won't do anything. And if I'm investigating, then I'll also switch to attacking. So this means if the enemy is either passive, like patrolling or idle, and sees something, they're going to attack it. And if the enemy is investigating and sees something, they're going to attack it. Probably before this one in your game, you want to check what's the who's the actor that they saw. Is it another enemy? Is it a player? Can they attack it? In our case, I can check like if this actor is equal to player, for example. So I'm gonna do a, let me move this here, do a branch. If actor is equal to player, get player character, then I'm going to attack it. Oh, and don't forget to plug in the attack target here. Yeah. Great. Let's test this out again. I'm going to right click and play from here behind the enemy. And if I go in front of him, yeah, he sees me and starts attacking. Perfect. Now let's handle what happens when the enemy sees something. So let's go back here to our AI controller and let's create another function that we're going to call here when we sense a sound. So let's create a new function, call it handle sensed sound. Now here what we want to know is where is the location of this sound we sensed. So I'm going to add an input, call it location. Location, yeah, and that's going to be of type vector. Again, we're going to get the current state first, get current states, and do a switch on that. So depending on what the current state is, we want to do something. And what is this something that we want to do? Well, we want the enemy to go into investigation mode. They hear something, they go investigate it. But we currently don't have a function yet to set state as investigating. We have set state as passive and attacking. So let's create a new one. I'm going to just duplicate this set state as passive and call it set state as investigating. Now, in this set state as investigating, we also need to know the location that we're going to go investigate in. And we're going to set the state as investigating. But we also need to pass this location to the Blackboard, so to tell the enemy to go to this location. And we don't currently have a Blackboard key for this. So let's go to the Blackboard and set it up. AI Blackboard. Let's create a new key of type vector. And I'm going to call it point of interest so that we can reuse it for other things. Yeah, and that's it. Make sure to copy this value and go back here to our AI controller. And let's get the blackboard. Say set value as vector. And the vector value is going to be this location. And the key name, let's promote this to a variable and call it point of interest key name. Compile to add a default value, and that default value is going to, oh, no, it's going to be exactly what I've written down here in my blackboard. So I'm going to copy it and paste it to make sure there are no typos. Great, so now we can switch the enemy state to investigating, but recall in our behavior tree, we don't have a state for investigating. We have a passive and a combat state. We're going to create one in just a second, but let's first finish our handle sensed sound. So here we want to set states as investigating. So if the enemy is passive, they're going to go investigate. If the enemy is attacking and they hear something, we don't want them to go investigate it because they're in the middle of combat. The enemy is frozen, they can't do anything. If they're already investigating, then this is actually interesting. So if the enemy is already investigating something and heard a different sound, do you want them to drop what they're doing and go investigate a different sound? I do, so I'm going to also plug this in here. And if the enemy is dead, they can't really do anything. And plug in the location to the states. Great, so back in our event graph, let's call handle sensed sound. Now, where are we going to get the location? If you recall, in this canSenseActor function, we also return the stimulus. The stimulus is the information about the specific stimulus we're looping over, which is this structure. And this structure has stimulus location. So that's the one we're going to be using. So back here in our event graph, break AI stimulus, get stimulus location, and yeah, plug it in here. Great. Let's see how this looks. Well, actually nothing's going to happen now. So the state will change to investigating, and the enemy won't do anything because, like we mentioned, it's not set up here yet. So let's do a very quick investigating tree. So over here, we're going to create a new sequence of actions. Let's call it investigating state. And just like the other two states, we want to add a decorator to it of type blackboard. Click on it and check against the state key. And if state is equal to investigating, then we enter this sequence. In this sequence, let's just do a move to. So do a move to. And the location is going to be the point of interest location vector we just created. And actually, before that, let's also set the speed. So set the movement speed, because yeah, when you go investigate something, maybe you want to be like not walking, but jogging. And finally, what happens once the enemy gets to the point? Let's say they wait for, I don't know, 3 seconds. And then if nothing happens to interrupt the tree, then they set state. Oh, we don't have, did we create that? No. So we don't have a task to set state, right? I thought we did. Okay, so when the enemy stops investigating, we want the state to go back to passive. So they go back to patrolling or whatever they were doing. So let's create this task just to make sure I don't have it. Wield sword. Yeah, we don't have it. Okay, so I'm going to create a new task of type blueprint base, put it in the tasks folder, and call it set state as passive. And this is going to be a very simple one. So event receive execute AI, finish execute. And all this is going to do is we're actually taking the AI controller and we're going to have to cast it to our enemy base AI controller and call set state as passive, and then just finish execution. All right, yeah, this is how it works. And over here, let's call set state as passive. By the way, I'm doing it in the middle here because if you recall, the order of priority is from left to right. So I'm just saying that if the enemy is in combat, that's the highest priority thing. If they're investigating, that takes priority over passive, and passive is the least priority. Great, so let's see how this is going to work. So the enemy should be... Let me start behind the enemy here. Now, if I make a sound, the enemy should go investigate where that sound is coming from. So if I press F now, yeah, the enemy goes, and you see they're trying to go to the sound, but I'm interrupting them. So they go, and even though they saw me, they didn't change their stance to attacking. This is because we didn't abort the execution of investigating when the state changes. So remember over here when you click on this blackboard decorator, observer abort, make sure to change it to self, so that if the state changes, for example, while the enemy is moving or while the enemy is waiting, then it should stop whatever it's doing and check if something of higher priority is happening. So now if I play, oh, all right, I should start behind the enemy. So now if I play and I make a sound, enemy hears the sound, but before going to it, they see me and immediately switch to attacking. So let's actually make a setup that you would see in an actual game. Have the enemy patrolling, have the player stand somewhere else, make a noise, and the enemy goes to investigate that noise. So I'm going to delete this patrol route, and I'm going to create a new one, just because I want a straight line. Yeah, and I'm going to put it somewhere here. So I'm going to have the enemy patrol along this route. And I'm going to have the player stand behind this wall. I'll just make it a bit smaller. All right, so here's our enemy. This is their patrol route. Let's assign it to them. And let's start playing from here. Now the enemy's patrolling and he doesn't see me. But if I make a sound, the enemy goes to investigate that sound. So I'm going to hide real quick. The enemy goes there, stays investigating for a few seconds, doesn't find anything, and goes back to patrolling. Oh, but because the patrol point was closer to the other side, that's why they went to patrol from the end. Great. Now if I make a sound and the enemy does see me, they're going to be like, oh, hey, what are you doing here? And starts to attack. Perfect. And that's kind of the functionality you'd see in a stealth game. Now let's add a final handler for our last sense. So back here in our AI controller, when we sense damage, what do we want to do? Depends on your game. Do you want the enemy to go to the player right away? So if you're not making like a stealth game, if the enemy is damaged, then they go directly to the player that damaged them. But maybe in a sort of like a sniper game, if you damage an enemy from far away, they don't know where the damage came from, so they don't know what to do. It really depends on your game. For me, I'm going to make it really simple. So handle sensed damage takes in an actor that damaged them. I'm going to be of type actor. And all I'm going to do is, well, first get the current states and do a switch on it and check which state I'm in. So if I'm passive and I got attacked, then I will set state as attacking and I will immediately attack this actor. If I'm already attacking and I got damaged, I won't do anything. If I'm frozen, got damaged, I won't do anything. If I'm investigating and got damaged, I will also switch to attacking. And notice here, I'm not going to check if the target is the player or not, because this target damaged me. So I'm going to assume that anyone that damages me, I can attack back. So that's what we're going to do. In your game, you may have friendly fire where enemies can damage each other but can't attack each other. Then you want to check for this, of course. Then back here, I'm just going to call handle sensed damage. And the actor is this guy. All right, so back here, if I play from here, enemies patrolling, if I press X, the enemy switches to attacking right away and comes after me. So they don't really need to sense me or hear me or whatever, because they automatically switch to attacking. And that was our perception system for our enemy AI. In part 4, we're going to be covering the EQS, or the environment query system, which allows the enemy to read information about the environment around them. So we're going to use it to position the enemy a certain distance from the player. And then you can use the system as well to move the enemy to cover, from cover, position strafe around the player, and so on. So I hope you enjoy it, and see you there.